ahead and get started. So with the first problem, it's just Pythagorean theorem. So maybe make a note. You're going to use Pythagorean theorem on this one. Okay, so Pythagorean theorem is a squared plus b squared equals c squared. So we got a and b here. A and b are the legs, and then the hypotenuse is c that we'll use in this equation. And then we plug the numbers in, and then we'll solve for c. So a would be 20 squared plus 21 squared, and then we got c squared, which is that hypotenuse length. And then 20 squared, you can do this in a calculator, or if you can do it in your head, cool, be 400. And then 21 squared, you do that in a calculator, get 441 equals c squared. And then add these two values together, you get 841 equals c squared. The last step is to take the square root of both sides to get rid of that square on the c. So you take square root over here, and c equals 29. And it just equals a whole number, which makes it easy. So this here is 29. And then, of course, make sure it's logical. The hypotenuse should be longer than these two sides. Okay, then the next one is very similar. It's a word problem, but what's nice about this problem is even though it's a word problem, they give you a picture, so you can use a picture to figure it out. We're going to use Pythagorean theorem again. So a squared plus b squared equals c squared. The difference with this problem, though, is like your a and b are the legs, and then they give us the hypotenuse. So in this case, we're actually solving for b right here. So you get 11 squared plus b squared equals c squared, which is 12 squared. And then we subtract 121 from both sides. B squared equals 23. And then the last step here to get b, we have to take square root of both sides to get rid of that square. Just draw an arrow over here. And b equals. So in the calculator, you just do 23 square root. You get this number. It says to round to the nearest tenth. 4.795. And it says to round to the nearest tenth, which would be that first decimal place. So we get b equals 4.8. Should I do zoom in more? Okay, and then the next one, it says find the area of the right triangle. So area of a triangle is 1/2 base times height. So this is your base and this is your height. We need to find this length though before we find the area. So the way to find this length is to use Pythagorean theorem. So we're going to use a squared plus b squared equals c squared to find this length. And then once we have the base, we can put it into this equation over here. So here, I'm going to use pencil. So for this equation, this is our a, b, and our c. So our a we're solving for, b is 8 squared, and then c is 10 squared. A squared equals 36. Take square root of both sides, and a equals 6. So that means this length right here is 6. And then we got 8. So then once we have this length, we can put it in the equation for area of a triangle. So area equals 1/2, the base is 6, and then the height is 8. Oh, sorry, I didn't realize it wasn't in the frame. So 1/2 base times height, base and height of the triangle. And then for this, you can multiply these in any order. You can plug it in a calculator, but 1/2 of 6 is 3 times 8, and then area equals 24 centimeters squared. Okay, next. Okay, so up here, this one right here still has to do with Pythagorean theorem. So for this problem here, a squared plus b squared, if it equals c squared, then we have a right triangle. A squared plus b squared, if it's greater than c squared, it's an acute triangle. And a squared plus b squared, if it's less than c squared, it's an obtuse triangle. So the way I can remember this, of course I can write it, like that might be a good way to practice it, but c squared being greater for an obtuse triangle makes sense because like if this angle is obtuse, then this side would be longer. Whereas if this angle was smaller, like acute, then this side would be smaller, which makes sense. So that's kind of how I remember. Okay, so then it says one triangle has side lengths 5, 13, and 12. Compute the sum of the squares of the shorter lengths. So the two shorter lengths here would be 5 and 12. So 5 squared plus 12 squared, that'd be 25 plus 144, which equals 169. So you put that number in there. And then 13 squared, you just do this in a calculator, just 13 squared is 169. So that means 5 plus 12 squared, 169, equals 169. So equals means it's a right triangle. Okay, and then the next one, we have 8, 11, and 6. So the two shortest sides are 6 and 8. 6 squared would be 36. 8 squared would be 64. 36 plus 64 is 100. So 100 goes in here. And then 11 squared is 121. So we have 100 is less than 121. So looking up here, that would be obtuse. So we choose obtuse. Okay, then next, we're honors only, we'll just cross that out. Okay, and then down here, these are the two, we're going to actually stop after these two. These are the special right triangle ones. So maybe write special right triangle, special right triangles. So there's two special right triangles. There's the 45, 45, 90 ones. And then 30, 60, 90. So for 45, 45, 90, it's x, x, and then x squared of 2. So like we're either multiplying by square root of 2 or dividing by square root of 2. And then for 30, 60, 90, it looks more like this. And we have the short side, 2 times the short, and then short square root of 3. How to keep this separate so it doesn't get confusing. Okay. So here, let's see. So this is a 45, 45, 90. So to go from this to this, we multiply by square root of 2. So we get 7 square root of 2. And it says to round our answer to the nearest tenth for this one. So for this one, we're going to plug it into a calculator and just 2 square root times 7. We get this number, which would round to 9.9. Then this one here takes an extra step because we have to go from this side to this side, so we kind of have to go around this way. So this one here, to go from here to here, we actually have to divide by square root of 3. So 4 over square root of 3. And then to get over here from short to the long, we have to multiply by 2. So it'd be 2 times 4 over square root of 3. Now we could go through and simplify this, but for this question, it just wants a decimal. So it kind of makes it easier because we can plug this into a calculator. Start with inside the parentheses. So I'm going to do 4 divided by 3 square root equals. So again, I did 4 divided by 3 square root equals, and then I'm going to multiply that by 2. And I get 4.6. So D equals 4.6. So as you can see, these are more of the harder ones that will be on the test. So yeah, take your time with practicing them. And then over here, this is the same thing. So just one more practice. This time we don't have to solve for a decimal. We're just making it in radical form. So let's start with the 45, 45, 90, which is right here. To go from here to here, we're going to divide by square root of 2. So 7 over square root of 2. We can't leave this as a radical in the denominator, so we multiply by square root of 2 over square root of 2 to get 7 square root of 2 over square root of 2 times itself is just 2. So it's this, 7 square root of 2 over 2. 7 square root of 2 over 2. And then for this one, multiply by square root of 3, we get 4 square root of 3. And that's it. Okay, so we are going to stop there for today. Here's what I want you to do with the rest of the class time. We didn't turn in our chapter 9 note packet yet, so turn that in if it's complete. If it's not complete, you can use the rest of class time to get it complete and turn it in. And then start your weekly Alex on a laptop. So wherever you need to be, just start there. Yeah. And then we'll